Hi guys, so we have an O-level past paper question from the year 2016. The session is May-June. This is question number 9. In this question, we'll use trigonometry to find the angle, distance and speed. So let's get into it. In the question, they've given us a wind turbine and the question reads, the diagram shows a vertical wind turbine with blades 30 meter long. The blades are stationary with the point A being the maximum distance possible from the horizontal ground. The point B is such that the angle of elevation of A from B is 34 degrees. That means this angle right here is 34 degrees. And the angle of elevation of the center of the blades C from B is 25 degrees. That means this angle right here is 25 degrees. It says calculate the distance AB. In order to find the distance AB, you will need to find this small angle right here. So what you do is you subtract 34 and 25, you get 9 degrees. So this angle right here is going to be 9 degrees. Let me remove the rest of this. Okay, when you have this as 9 degrees, remember that this was 25 degrees and we have this as 30. We need to find the length of this side. We at least need one more angle, so let's find this angle right here. How do we find this angle? We add 25 and 90 and we get 25 plus 90 plus 25 gives us 115 degrees. This angle right here is 115 degrees. Now we use the sine rule. So in order to use the sine rule, we do sine of 115 over AB, that's the length that we are looking for, equal to sine of 9 degrees, which is equal to 30. Then we cross multiply them and let's see what we get. We multiply sine 115 times 30 and we divide that by sine 9. The value that we get is 173.8 meters. So your answer to part 1 is 173.8 meters. Okay, the next part of the question says a different wind turbine shown in the diagram on the next page has the center of its blades F 75 meters from the base of the turbine D. Point E is on sloping ground 180 meters from F and 130 meters from D. Calculate the angle of depression of E from F. This is the diagram that they're talking about. So in order to find, I've already highlighted that in order to find the angle of elevation of E from F, you will need to draw a horizontal line over here because this would then be the angle of depression. So this is the angle of depression. How do we find this? First, in order to find this, we will need this angle right here. When we have this, let's call this x degrees. When you have x, you subtract it from 90 and you'll get the angle of depression. But how do we find x? So in order to find x, we use the cosine rule. In the cosine rule, the length in front of x, we use that 130. So we write that in front of the equal sign. 130 squared is equal to, this side is 180, this side is 75. So we write 180 squared plus 75 squared, one second. Okay. Minus 2 times 180 times 75 times cos of x. Now I want to isolate cos x, so I take everything on the other side. So I do 130 squared minus 180 squared minus 75 squared. This is a square sign. Divided by negative 2 times 180. I literally took everything on the other side, so that I can plug this entire thing into the calculator, this entire thing into the calculator. Let's see what we get. We do 130 squared minus 180 squared minus 75 squared and we divide this by negative 2 times 180 times 75 and we end up at 0.7824, and when we do the cos inverse of this thing, x comes out to be 38.5 degrees. So when we have x, we need to subtract this from 90 degrees in order to find the angle of depression. So you do 90 minus 38.5. When you do that, the angle of depression comes out to be 51.5 degrees. So you write the answer over here, 51.5 degrees. This angle right here is 51.5. Okay. The next part says P is the point on a blade which is furthest from the center of the blades. Each blade is 30 meters long. Calculate the distance traveled by P as the blade completes one revolution. So technically P is the point over here. That's on the edge of the blade. So when it completes one revolution, that means it completes one circle. To find the revolution, you would use the circumference formula. So the circumference in this case is going to be, let's say it's P, I don't know, let's call it P meters is equal to 2 pi r. So when you do 2 times 3.142 times 30, eventually when you do that, you get 189 meters. So one complete revolution takes 189 meters. The next part says the blade completes 15 revolutions per minute. Calculate the speed of P, giving your answer in kilometers per hour. So how to find speed? The formula for speed is distance divided by time. Distance in this case is 189 for one complete revolution, and it completes 15 revolutions per minute. So you do 15 times 189, divide this by 1000. Why do we divide it by 1000? Because 189 meters needs to be converted into kilometers, and then you multiply this by 60. Why do we do that? Because this was 16 revolutions per minute. When you multiply 1 minute, 15 by 60, that would give you the revolutions in 60 minutes. So let's do this. Let's plug this into the calculator. 15 times 189 divided by 1000 times 60. This gives us 170.1 kilometers per hour. So we write the value over here, 170.1 kilometers per hour. The next part says a point Q lies on the straight line between P and the center of the blades. Q travels 90 meters as the blade completes one revolution. Calculate PQ. So what it means is that a point Q lies somewhere between the center, which is F, and P. So let's say it lies over here. Okay, let's say this is Q. We don't know what the length of FQ is, and we need to find that. That will be the inner radius. So first we need to look at this piece of information, that when it revolves, when it completes a revolution, it covers the distance of 90 meters. That means the circumference that it covers is 90 meters, and we need to find the radius over here. So you do 90 meters is equal to 2 times 3.142 times r, which is the radius, of course. So r, let's do r. We do 90 divided by 2 times 3.142 r. Let's see what it comes out to be. 90 divided by 2 times 3.142. This comes out to be 14.3 meters. So the distance, the larger radius was 30 meters and the smaller radius is 14.3 meters. When you subtract the two, you get the distance PQ, which in this case is going to be 15.7 meters, and this completes our question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.